Hey, what's up guys? Welcome to Developer. This is Ayush and today in this video we are going to be implementing DFAs. So finally, we have gotten to this point where we can finally start implementing DFA. And well, not exactly the implementation in this video. This video is going to be covering the basic setup of our project and how we are going to be modeling our DFAs, like the things we are going to be structuring and other low level design if you will. That is what we are going to be covering in this video. So let's start with the first thing. Well, let's go over the basic project structure first. So what I've got over here is just a basic simple CMake uh, project. Well, the build system of this project is going to be CMake, and this is the CMake list.txt. Let's quickly go over it first. So first we define the minimum version of CMake required to build this project. Then we define the project name and the project language, which is C. Then we declare that the include directories are going to be project source dir include. So this folder right here, and we create a sources variable which will recursively glob over the sources directory, find all C translation units. Then we set the CMake build type to debug so that we are able to debug our code if we get stuck somewhere. And then we create the target with this add executable command. The name of the executable is DFA, and these are the sources which it takes to compile. Okay, with that out of the way, let me just show the build sh, build and run sh, and clean sh, the three scripts which I've got over here. So this just simply builds the project, these cmake export compile commands on. This is for clang thing, so that we get this particular file over here. Well, actually it will be created over here, but we have symlinked over to the project source directory. Okay, well, that was easy. Now let's go to what next line does. CMake double dash build. We specify the build directory, which is build. So currently it is hidden. This is the build directory. Let's go over the next script, build and run. Here we basically just call the build script. Then we change directly to our build directory. We then just print just a basic message which says that we are in the build and run script and build and run finished. Well, we have used double ampersand, so this will execute only if the prior two commands have already executed and returned without failure. So output from here is now from your application. Then we run the application, which we know is called DFA because we have named it as DFA in our add executable where we define the target. So the target is named DFA. Okay, clean sh. Here we just we specify the build directory and the target to be clean. Well, this what essentially does is it will delete the project, the target. Basically, this DFA executable, it gets deleted. So let's see what we currently have as far as the source code. So in the include directory, it's empty. We have nothing over here. In the source directory, we have main.c, where we have just a little boilerplate of hello world, nothing very fancy. Let's just run it and see what it does. So I'll do build and run sh, and as you see, we get hello world printing onto the screen. So this is how we are going to be doing things mostly throughout this video. Um, well, before going to the actual implementation of DFAs, let me quickly just point out that if you have missed watching the video of DFAs, what DFAs are and what they do, where they are used, and their applications and whatnot, you can, I'll put a card up top, you can go to this video and basically see for yourself what DFA does. Let me quickly bring up my very reliable demonstration which I gave in that video. We have our two DFAs. The one on the left is a very simple one. The one on the right is another very simple one. So what our main focus over here in this video is not going to be implementing complicated DFAs and complicated DFA logics, but we are going to be only focusing on actually how we can build a DFA in C. Yeah. So let's get right on with it. Let me just reiterate a few little things. Let me go over them very quickly. So DFAs, what they are set of states. DFA is a state machine. It has a set of states and a transition function which governs the logic of transition between the two states. DFAs take input as strings, and based on if the final iteration of that string, like taking on a character one by one, if we finally reach the accept state of the DFA marked by these two circles over the state letter, like Q0 over here being the accept state and Q1 over here being the accept state in the second DFA on the right. If we end up on this accept state, then we finally accept that string. If we end up being on any other string, then we reject that string. The state which has an incident arrow, means coming from nowhere to it, is the initial state. So Q0 being the initial state over here and Q0 being the initial state yet again over here. Q0 is the accepting state here, but Q0 isn't the accepting, rather the rejecting state over here in the second DFA which I have on the right. Okay, well, that was easy. Now let's first discuss how we can implement DFAs, or basically let's design before jumping onto writing code. Well, it's not going to be a very uh, big thing to discuss, so we'll keep it short, we'll keep it quick. So we can, by looking at the DFAs, we can imagine to create a struct called state. So because DFAs have state, and then yet another struct DFAs which will contain these states. Because this, let me quickly get my drawing pen and draw something over here. This is a DFA. Well, I'm using the mouse to write, so pardon my handwriting. It's not really that bad in real life. Yeah, trust me, guys, when I say that. I actually write pretty good. So this is a DFA, and this is a state. Well, let me not bother writing that. State. DFA contains states. If you are observant enough, you will see that DFAs not only contain states, but also the information of the initial state and also the transition logic between these states. Well, this transition logic between these states, we can keep that at the state level as well, keep it at the DFA level as well. So a DFA can have a map uh, governing when Q0, for example, say state Q0, what input arrives to it and what is the destination state for it. So Q0 on taking input A stays at Q0. Q0 on taking input B goes on Q1. Similarly, Q1 taking input A or B in both cases stays on Q1 itself. This transition logic, the table, sort of, let me draw that for more clear visualization. So this can be the transition function where we can have this Q0, Q0, Q1, and our inputs A and B. Well, Q0 taking input A stays on Q0, Q0 taking input B goes to Q1, and Q1, whether you give it A or B, it stays on Q1 itself. This can be modeled as a two-dimensional array inside of our DFA and stored over there. Now, what we can see is that either we have this transition function information as part of our DFA, or we can have the state somehow know that, well, if the state is Q0 and it is taking an input A, then we can have a function over here which says, yeah, if you're taking input A, well then you need to go to Q0 itself. So a function which takes in an input character and returns a state or pointer to a state, whatever seems comfortable while implementation, will take that. Similarly, Q1, which takes in A or B, and there is a function which knows, well, let me call this F2, this will be F1. These are two different functions, and it will know that it is going to transition to Q1 regardless. So something like this. We can implement it both ways, both are fine. Well, but in this video, we'll be implementing it the second way because, well, we'll see one interesting way to traverse graphs. So, well, this DFA over here, we'll see an unique way of traversing it. This is, I'm not saying this is wrong in any kind of way or something like that. This is perfectly fine. Go ahead and do it. Well, but let's keep the X factor up for this video and start implementing it with this way. So this one is DFA owns the transition function. DFA owns, DFA contains delta, which we use to denote the transition function. And here the state owns the transition function. So with that explanation done, I would like to call quits on this video. That's it for this video, guys. In this video I discussed on the design of the DFA which we are going to be implementing in the next video. So yeah, that's all I had time for today, guys. We'll be uploading the video for implementation of DFAs very soon. Stay tuned to the channel for it. Drop in your suggestions in the comment, drop in your reviews in the comments. I would like to go through and read them. Yeah, till then, keep learning, keep growing, keep making mistakes. See you later. Bye bye.